So another Friday, another video. Today's topic, I'm going to be talking about magnifying glasses. And not just any magnifying glasses, but what we could do with these. So what could we do with these then? Good question. So if we imagine this as concentrated sunlight, what I like to call it, concentrated sunlight, very good. So let's say the desert, for example, just sits there doing nothing. We could use that. Well, to do what? Lots of things. So, as always, I will flip the camera around and we will look at these documents in more detail. But just to give you a quick rundown, quick heads up, magnifying glasses, these. And a nice table, if you like, heat-proof as well. It can take the heat of this, beaming down on it. Now, what the difference is, that if we were to put different types of material on the table, could we melt it? Possibly. Could we use it to shape metal? Maybe. Or here's another one. Could we use this to concentrate the beam of light, let's say? I like to call it a magbeam. So if I talk about magbeam, that's what I'm on about. That little bit that when you get it just in the right angle, you get that really hot beam. So magbeam. So if we were to take the magbeam and aim it at a container filled with salt water or fresh water, doesn't really matter, but salt water, for example, could we not use the heat from this to hit the container in the right place with a little element underneath it that then runs into the container of salt water, and use this to start heating up the salt water? And as the sun moves across the sky, so will this chase it, but always keep its beam on the tank of water. Why would you put it on a tank of water? Well, if we started evaporating this water really readily in several different containers at once, because I mean, you wouldn't have one of these, you'd have several of them, and they'd just chase that sun. And each one of these would then aim towards a container filled with salt water, and it starts bubbling it up, and it gets all excited. All those little water particles, let's call them hydrogen, oxygen particles, start getting really excited. And as they do so, they start banging into each other and then create this thing called pressure and steam. And let's say these containers can take a lot of pressure and thus a lot of steam, and as soon as it releases this, blows out the top like you're releasing the lid of your steamer, we could use this to spin a turbine, maybe. And okay, it's not power that's going to give you power all the way through the night, but it is going to give you power during the day. So could it work? It's possible. So that's not really the whole point of this video, to be honest. The more of the point is this: if we can place metals, quartz, iron, steel, copper, and if you remember from my couple of videos back, when I was talking about these tombs where we heat and melt the metals over a volcano, and then when we've got those slabs left over, could we bring them to the table and start shaping them using the magnifying glasses? And that concentrated version of sunlight hits into it. Ooh, could we? That's the question I'm asking. Could we go a step further, and let's say the electricity one, producing electricity from it wasn't too great? It is good, but not great. It's not continuous, it's not 24 hours a day. So, you know, that one might not, but it could, on the hottest days, give more energy to the grid. So let's say if we use solar panels and wind turbines, and okay, it's a beautiful sunny day in America. I use America as an example because it's very big and it's really hot, and people are all turning on their air conditioning units, and the solar power, yes, although they're receiving quite a lot of sunlight, maybe they need an additional boost of power on those hot days. So when people start turning on their air conditioning, this might heat the tank, cause the pressure, turn the turbine that then sends an extra kilowatts worth of energy, let's say, 00, who knows how much these could create. And another thing this could do really well is release a lot of steam. Now, you don't have to release the steam, you can collect the steam, vapor, condense it, and you'll have a purer form. So you might be left with salt crystals in the original containers you set the magbeam on, and you get some salt crystals build up in there. Sure, but the steam vapor that then condenses back into another tank would be more fresh air. I wouldn't want to say completely free of salt. Maybe you need to do this process a couple of times before it becomes completely salt free. But if you were to run this one, steam it off from the salt water, collect it once it condenses back down, and the beam then moves over to the other container and it does the process again, and then you collect that again, you're then making drinking water as well. Are you using any energy? No, none whatsoever. Zilch, because you're using the sun's energy, the same much, I guess, in a different way, but how plants use the sun's energy, you're using it no differently. So yeah, it's gonna maybe help in that aspect. And the byproduct of this is, well, it could power a turbine that's sat on top of here once the pressure had built up enough. Now, I'm not saying that this turbine is going to continuously turn. It would be more like hiss and popping. So one would hiss, pop, power a turbine, then another one would do it, and they would all have different times of when they would go off. And if you could get the consistency right of one bursts, another one bursts, another one bursts, another one bursts, another one bursts, these each turbines, although they are not spinning constantly, but when one finishes spinning, another one is then spinning, and then when that one finishes, this one might have charged back up again, or another one is spinning until this one has charged back up, and eventually what you have is this runaway effect. So there are quite a few benefits from this. Number one, you will be creating fresh water from salt water. If you allow it to escape and go into the atmosphere, I think Britain will become wetter again. We will definitely have full-on month of April showers. Oh yes. And when you think of London, you'll think to bring an umbrella with you. So you could dampen back up the environment. Too much of this is never a good thing, and not enough of it is never a good thing. Oh, we are in this happy medium of everything. Too much of something, not good. Not enough of something, also not good. Somewhere in the middle, that balance, I love balance, that is where we need to be. So yes, we could release these into the environment, maybe. Or we collect it and let some go out into the environment, the atmosphere, and some we collect for drinking water. Hey, double whammy. So the salt that then would build up in these systems, we would be very wise not to go throwing that back into the ocean or leaving it on the land. We should contain it, give or take. I think we should contain the salt crystals that may form and store them away so that if we have lack of salt in the oceans, could you ever imagine that? But yes, eventually we could turn the salt water, the oceans, into fresh water. How crazy would that be? If we did this too much and just kept collecting the salt over and over and over and over and over until it started mounding up everywhere, we would then lower the salt levels in the ocean. So we might need to put some of this salt back. But that's going to, again, balance is key. We don't want to take too much away, but we don't want to put too much there either. So collecting some and maybe letting some out, but collect it most of the time, I think would be a beneficial way or approach to this, not to over salt the oceans. Wow, we got some tongue twisters today. Tongue Twister Tuesday. I mean, but it is Friday, but still, you know, I think we might hashtag that one in for a Tuesday. Tongue Twister Tuesday. Whew. Think of the most tongue-twisting, mind-boggling lines you can think of. Producing. I don't know. Might save that. I'm going to stow that one away for later, but yeah. So at the moment, we're Fabulous Friday. Hashtag. No, I'm just kidding. But, so yeah, back onto this. So I just wanted to touch upon that just really quickly because wherever Area 51 is, I believe is a desert there, is Nevada desert. Can't be 100% sure. So I'm not going to sit here listing all of the deserts around the world, but yes, most of the deserts around the world could use this process to generate fresh drinking water, a little bit of power, perhaps a power boost to the grid. Um, Maybe. And would you be using any fossil fuels? Nope. Would you be creating any pollution? Vapor, if you didn't collect it? If you did collect it, would you be creating any pollution? No. So you're covering all of your grounds with this one. So all this comes from is a magnifying glass. Now, will this get hot enough, this mag beam get hot enough to heat the water inside the tanks? Yes. If done correctly, yes. There should be no reason why this would not work. So, is it enough to power a generator? I don't know. Or a turbine, I should say. Enough to power a turbine. Maybe, if it was done correctly. Why not? What if you had series of bottles? I call them bottles. Probably be water containers. But anyway, with their little elements in it, the mag beam hits the element. And this series of containers that then move one to the other, and the mag beams are all positioned in a way that covers half of it, and you have the generators just sat, or turbines, sorry, sat on top. 1, 2, 3, 4, 5, 6, 7, however many it will be. And then once those ones have pushed their liquids out, another one moves into position, and it moves and it moves and it moves and it moves, so that you've constantly got this popping and fizzing effect going off. So when one's done, another one move on, and it moves on, it moves on, it moves on. So robotics might be able to help with that. So, moral of this video, because I want to try and keep this one short and sweet, because some of them I'm producing out there about an hour, so whoa, I could go on about these subjects for a long time. So I'm going to try and keep it shorter. So this is more the moral of this one. So we have nice sun here, hee hee. And we've got the magnifying glasses, and we've got the mag table that would be heat proof enough to withstand a lot of this. I don't think prolonged contact it would, but yes, would we lay out our metal on here? Who knows? And I have the mag beam in just the right distance away from the table, that concentrated heat beam or light hits the table, and it covers a very, very vast area of the table. Thus, for the slab that is laying on top of metal, if you wanted to make cans from it and you heat it up, and then you have some other device that comes and rolls it, get that nice cut into shape and position. Could we solder stuff with it? Could we seal the cans? Could we make cans? Could we make tins with it? Could we make rods that are going to be used to go inside concrete, cement, concrete? I never know which one it is. Both. Fight amongst yourselves, chime off in the comments, let me know which one it is, concrete or cement. I always thought cement was wet and concrete was set. Who knows? Or maybe they're just both the same thing, they're just different way of saying it, so who knows? So another thing working with piling, you think I would know this about concrete cement, wouldn't you by now? So I'm going to call it cement. So when we were pumping the cement, doing piling, using a great old pump, and then the pile, the rig or the auger would backwards itself out, start backing out the hole it's made. We would then pump in cement, and as this then retrieves its auger, the cement would fill into the hole, and slowly but surely you'd have a hole in the ground, top layers here, bottom of the ground is here, movable layer of earth is here, and you'd have your pile sat there and your tube of cement, and then you would stick in a metal or steel cage, would then be pushed into the hole, and then once it sets, you then have your pile, practically. And yes, so if you needed those cages made, I just wonder how you melt these. Does it use fossil fuels? Does it create a lot of energy from solar panels? Do you need a lot of solar panels to get this stuff to melt? I'm just not sure. So would a volcano number 1 melt this all down into a slab? And would this one allow you to either A, cut it into shape, and once you've got it into your bar that you've taken off of your slab, would you then need this to heat it, to twist it? Would you then need it to make the cage completely together. So you could make the whole cage that you just push in rather than build the cages on site. So again, could it save time? Who knows? Would this allow you to shape different metals? Could you cut different metals with it? Who knows? That is the idea of this. And then quartz. Could you crush some quartz up, and then heat it up? Would you need it to make solar panels? I don't know. Maybe manufacturing solar panels, making motors, giant motors, or turbines. Either way. Alternators, would you need these to heat certain bits of it up to get them into shape? Making cars, could you use this to mold things? Could you mold the metal into shape? It's basically using a magnifying beam. Would you then be saving the grid's energy? So let's say we had solar panels scatting everywhere, and then we go into the future and we've just got a planet of solar panels. Wouldn't that be great? But still, would they generate enough? That's the question. Is it always going to be windy? What do we do in the winter? I've already got some other plans going on there, so those ones I'm not going to reveal just yet, but we're going to get there. And then the sun goes down, so do we have enough in a day to make these, or could this be another way of doing things? So you have some companies that use solar tech to make what they need, and other companies use magnifying glass. Tongue twister. So, you know, I don't know, that's basically what I'm thinking of. So I am going to flip the camera around and go into more detail on this one, just so you can see it, have a look, and just grab the concept. And if there is anybody out there who is interested in building one of these, or several of these, yeah, maybe this might help you, you know, blow some creativity your way. Is it possible? Can we do it? Yes, no, maybe. Let's give it a go. Shall we try it on a small scale and see what happens? Yeah, definitely. This is just one that I'm thinking about. Okay, it doesn't generate power 24/7. That's the only thing. Nor do solar panels. So we've got tea time power to think about. That's coming in the next. That's going to be quite a future video. My cat's just jumped up. Wants to come join in. So that's going to be done in a future video. Isn't that right? But probably 4 weeks from now, and I'll start to reveal a bit more of those. I just want to get them copyrighted, and then I'll start talking about power that goes and is able to be generated 24 hours a day, day and night. Nice way to end this little video. So I'm going to turn the camera around now, because, you know, and this is Mussy, or Butts. We call him Buddha Mussy, so I'm not going to edit him out, because he's great. He loves to bite, don't you? But anyway, so yeah, leaving it here, and I'm going to flip it over. So see you in a sec. So here we have it. The quartz melting for solar panels, shaping metals, and melting, etc, etc, etc. And here it's not hard to see how we could use this, replace this with a canister, let's say, and it would heat water, evaporate the water, collect it, condense it, make fresh drinking water. Again, still wouldn't use any electricity off of the grid, so self-generating, I suppose, in a way. Just taking the natural processes that happen and amplifying it using a magnifying glass. So, would it work? That is a very good question. It might not, but I would say it would. I don't see why it wouldn't. So if you imagine all of these are a series of magnifying glasses, and then you have the magnifying beam. So, I almost had a stutter on that then. Works better with broom. Anyway, so we'd take the beam and aim it towards a cylinder, or we have multiple of these beams, and obviously it would be angled in a different way because my sun is over there, whereas this sun is over there, so it would shine and come at a different angle, and it's not hard to understand how this would then heat the table or any metals that we had on it in order for shaping. If we were to spin something here and hold it underneath here, I think it would stay in shape as a cylinder. Could we also put big slabs from the volcano one? I don't know if you saw the video. If you skip it to the end if you want to miss out the yada yada explanation. At the end of the video there is a drawing of, I don't have it to hand. I probably do, but it's probably buried behind all of this paperwork. All of these are drawings, so there's a lot to go through on these. So it's behind here somewhere. But anyway, if you were to skip the video, you would see it, that there are these, it looks like a bell, and you hover it over a volcano, put all your shards of metal in there, and it will then melt your metals, and you would have just enough metal in there to make a slab. Once you've got the slab over the volcano, it melts the metal into a nice, uniformed, neat, lovely slab. And then you'd move that, undo the bottom part of the bell, and then knock out the slab. Once you've then got that, you could move it to here. I suppose using these to... what was another one that I did make? I have that. I do have that one. It's up on the wall. Let me get it. Got it. That was quick, wasn't it? So here, this is automatic lens magnification. Same process, but it uses a magnifying glass to sit here. Here you have your solar panel, and when the sun starts to set, and just in the morning at sunrise, if the magnifying glass was more further away from the panel, it would concentrate the light onto the solar panel, boosting your light production on your solar panel in the early morning, maybe. And then as the day progresses, because you wouldn't want the magnifying glass to melt the solar panel, it would then slowly by, I don't know which one have we got it here, by 10 AM would be nice and close to the panel, so it wouldn't be causing much magnification. And then as the sun started to set, here we have some pulley system, as the sun starts to set, it slowly starts to lift the magnifying glass or lens to get more enhanced light. So I think when you look at solar panels in power production, I think they are quite low at sunrise, and if you take the power output, if you take the power output, it comes up and it peaks around, I don't know, I think it's like from 11, 12, 1 o'clock, 2 o'clock maybe, and then the power starts to dwindle slowly but surely. If you've had solar panels, I'm pretty sure you would see this for most of the, if you're not taking any power off of an inverter, you'll have peak power and it would float at around, I don't know, from maybe 11, maybe 10 AM until, I don't know, sometimes 3 PM on good days, and then the power would start to dip. So you have this window of constant beefy power, let's say, and then it starts to dwindle with the sun that starts to set. But this one was using a magnification lens that would sit above the panel, so that as the sun, as we moved from 3 PM, it starts to lift up. See, I got it here, 3 PM, yeah. And it will start to lift until you get to about 6:30 PM, and it should allow you to keep this constant. It basically moves the window of power so that you have it for a longer time. So I don't know, so from 8:30 AM until 5:30 PM, maybe even 6:30 PM, you could have a lot more power, beefy power, from those times rather than a shorter time. So it just lengthens the amount of time that you could have power. So yeah, that's another idea that I was thinking about quite a while ago. Can't remember when it was now, doesn't really matter, probably not. It's on my no, this one is not on my website, it's on my Facebook. So if you were to scroll down quite a way down, it would be there. So that's that one. Using magnifying glasses just to concentrate the sunlight, boosh, and put it on the panel to make it go a little longer. So there's one. Another one is to melt metal, quartz, all sorts of stuff on here. Shape metal, different stuff. Could we use it to cut metal? Maybe, maybe not. But could we use this idea to power some tools to cut the metal into shape? And this is more for shaping, but if you needed, if it was a slab of metal that you had and you only needed a tiny fraction of it, you could then use this to power your tools to cut it. Another thing it could do is if you had a container of water and an element, and the beam hit the element, which then got really hot inside the water, caused the water to boil, salt water, and it were to evaporate inside the container and build up with lots of pressure, and then you release this pressure and have a turbine sat at the top of it, and then it could generate power from the steam or pressure that's built up. And if we were to collect the steam that then came out of the system and condense it into another container beside it, and you use salt water to start with, you would be able to make fresh water eventually. Keep repeating the process, you would then be able to make fresh water. And did it use any electricity off of the power grid? No, it didn't. Did it add power to the power grid? Well, yes, via this process, and also yes, via the steam and pressure whizzing through the turbine at such speeds. It then spins the turbine, which then generates the power from the motor, and it could increase daytime temperature. So when the temperature gets at peak heat in the day, people start to turn on the air conditioning. It then demands more power from the grid. With this in mind, that it works better when you have those days when it gets really hot. It could then heat the water, push that through the turbine, and give a little bit more additional power to take the load off air conditioning units, if anybody uses them. So, which most people do. But if they were to use them at those particular times, it would just give you a little bit more energy to stop any blackouts, potentially. So that's the idea of this one. And obviously this here is on wheels, for sure. And it's a moving platform that chases the sun. So obviously the sun might start over here and move itself across the sky, and the Earth's spinning, blah blah blah, and the sensor would track this and move with it to keep the beam at the right distance, so that the magnifying beam, or the mag beam, is always on the table no matter where the sun is in the sky. So this unit would move with the sun, keeping at the right distance so that it's not too close to the table, and that the beam moves through it, let's say, and it's not too far away, so the beam is not got its same intensity to melt, burn, heat, or do any of the other. So this will always stay at a good sort of ratio to the table, so that the beam is always on the table. So there would be another sensor on the table that would feed information into the sensor on this unit here, which moves, and it always tells the robotics inside here, or the computer inside here, where it needs to be from the sun. And another one tracks the sun, so if the sun starts over here and the beam is over here, it moves with the sun. But not only moves, it keeps the right distance, keeping that right ratio to keep the same intensity of heat on this table, or whatever you have on it. These are heat-proof insulation bricks, so that we don't lose any of the heat going through to the ground. Would this heat the environment up? Again, that's a good question, so contain it if that is a factor or a worry. Another thing that you could do if it was generating large amounts of heat is, this one is going to be another video in a little while, but if you see these here, these are just ordinary, I don't know, iron rods that are shaped in fan blades. Now, if you've ever had a coal fire or a log fire before, you can buy these ironworks fans, if you like, that you put on top of your log burner, and from the heat convection it spins basically the iron fan blades, and it pushes the heat away. It doesn't use any electricity, it just uses the rise of the heat from your log burner to spin the the iron fan, if you like. So with that in mind, if this was generating a lot of heat on the environment and it started to rise fast, if you were to put a bracket over the top that looked like this, an arm over the top, so put one in the ground, one going across, and you put these same iron fan blades underneath, and rather than having it just spin and do nothing, why not put some motors on the back of those, and every time the iron rod spins from the heat that it's generating, it would also generate electricity. So when you think about this idea, I don't know, in the way that there's so many uses you can get from this. Okay, maybe it's not going to give you power at night time, fair enough, but it might charge batteries to give you some power at night. It would take the load off of the electricity grid when people start turning on air conditioning units. Would it work in the winter? Well, that all depends on the heat in your desert. If you have a desert area, say if America has a desert area that is very, 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 very hot, and it is in the winter as well, then yes, this should work, and it might give enough power to power heating devices. I'm not 100% sure. Yes, okay, the position of the sun will affect how much of a beam this will create and what intensity that beam will be. That will need calculating, and once you've built this, you will then know as the year goes on, you'll find out whether you do have enough energy in the winter to create the same amount of I don't know, knock-on effect to power turbines, knock-on effect to power these iron fan blades, if you like. Maybe they'll spin at 1,000 rounds per minute, and in the winter they'll spin at 800 rounds per minute as opposed to 1,000. So it's still generating power, just not as much. Always that is a possibility. If you had the desert and you still had using these lens magnification, here you could then put it to solar panels that were in the desert with lens magnifications to give you a little bit of a longer window, to give you some extra power in the winter. I don't know. The more closer to the equator you go, the more stronger this beam will be. So it will generate a lot of heat. You can generate water from salt water using this idea, and I think that's the kicker for me. That's the one that gets me quite going a lot, because you know, generating clean water, I think, is quite a process, let's be honest. And does it use a lot of energy? Well, to heat an element inside a barrel of salt water and allow it to steam and then collect the vapor, I think requires quite a lot. Some of your elements inside your home are up to 2 kilowatts, 3 kilowatts of energy. If you want to find out how many solar panels you need, how many inverters you need, just to do one immersion tank in your house full of water to get it boiling, and then you don't want to get it to a boil and then turn it off. You want to keep on boiling it and keep grabbing the steam that comes off and then allow that to condense somewhere else. So no, it's not as simple as where you heat in your home for your immersion tank. It gets it to a temperature and then it turns off. It doesn't boil, keep going until everything in that tank is evaporated, and it has to keep replacing more water. So, you know, that's not what's going on here. This will have to keep on going. It's like leaving your immersion tank on all day, every day, just to make some drinking water. So if you understand it in that process, it is very expensive to make pure water, let's say, from salt water. So to eliminate this a little bit more, this idea could be the one that works. And not only there, why stop there? Why do water? You could do other things, metals, quartz for making solar panels, put them on solar panels to generate more power. Once that magnifying beam is heating another, let's say, if you were to contain this in a cylinder, you have a massive cylinder that's hollow, and you put a load of these inside it, metal ironworks, or you can make them out of a material that's so light, it's lightweight but doesn't burn or melt in the fast vacuum, not vacuuming, the fast, I forgot what it's called now, but anyway, it will come back to me in a minute. So when the air travels up, convection. So if these can take the heat from convection, and you find a material that can take the heat from convection, and you make a cylinder, you then have these aimed into the cylinder at the bottom on a, I don't know, a metal plate, and you make some holes around the outside so that when the air sucks in the cold air and the hot air then begins to rush upwards, which would then travel through these fan blades that you've made attached with motors on the back of them, it would then start powering these to spin, and you can then use magnifying technology to make these move via convection, and once these start spinning, you can then generate electricity without actually needing any electricity in the process to create it. These do not use electricity, they use the sun's rays to basically concentrate it on the plate. It heats the plate gets hot air rises up, it then sucks in from the vent holes you've made in the bottom of your cylinder into it. That heats and pushes up with the hot plate, and you know, this process could run on for as long as the sun was up, and these were aimed and trained at that plate at just the right distance. You don't want the beam to be too close so it melts a hole in the plate, and you don't want it too far away so it's not heating enough. But somewhere in between that, there is a balance, and once you found that balance, you can then, you know, generate power during the day. Now, I'm not going to say this is going to give you power at night, but imagine if you were powering a lot of these motors, or turbines, I'm sorry, and they were generating enough power that then fed a load of batteries that you could then give it at night. Okay, it wouldn't be great, it wouldn't be maximum amounts, but I think having a bit more power at night is better than not having any at all. So it could work. So as I say, I'm going to be moving on to another idea in the coming weeks. It's probably going to be within 4 weeks, where there is an idea and a process that I am working on where you can generate power 24/7, but that is just not yet. I'm still in the design stage at the moment, so I've scribbled all of my scribbles like this, and then I'm going to put this one straight onto computer version and make it all nice and neat. This one was quite simple, so I didn't really need to do that. So permanent marker around the outside of the penciling, and it looked pretty good, so stuck with it. So yeah, that's this one. I'm going to move on to another video where I'm going to be talking about this one, so that this one isn't so long. But yeah, just from one magnifying glass, which then uses the sun's energy, look how much energy we can make from this. It's basically another version of a solar panel, but this one doesn't require quartz. So it could work. Not saying it will work, but it could, and it should. There should be no reason why it wouldn't, using convection, because it's what happens. Heat rises very fast, and especially if we caught it inside a tube, and inside this tube of this convecting air, it would spin turbines. We'd put turbines inside it, and it would just spin on the movement of this air. So, you know, nice lightweight, good old dynamo, and off you go. And then do you need one dynamo, or could you use several of them in series motor? And you've got your spinning fan blade, and then you've got another motor above that one and a spinning fan blade, and all of them spin. So basically it'll be a tornado in a tube. And with this tornado in air that you've got going on inside there, you would then be generating power from it. So man-made tornado inside a tube that couldn't go anywhere apart from within the tube, you would then make some sort of tornado power. It's crazy, I know, but bear with me, you get how it goes. So yeah, as I say, I'm going to leave this one right here. It is 5:30 now, so I'm going to get on and make one more video for today, and then yeah, I'm going to go and do some more drawing and business planning. Excellent. So yeah, good old Friday. Have a fabulous weekend, everybody. I hope you are being safe and keeping your distance still. Excellent to hear if you are. So brilliant. Have a fantastic weekend, and I will see you either in the next video, which I'm going to go and make now. Whether I post it on the same day is a different story, but if not, I'm guaranteed to see you in next week's video. So until then, have a great week. Have a great weekend. See ya. Bye bye.